Welcome to Unlocking Spacetime. Today we will explore one of the most intriguing and powerful phenomena in space, the elusive and captivating black hole. Black holes are among the most powerful objects in the universe, where gravity is so intense that even light cannot escape. These invisible giants are born from the collapse of massive stars, their pull so overwhelming that everything around them becomes trapped, suspended in time. Despite their threatening reputation, black holes are not places of fear but of wonder. Objects so strange, so foreign to our everyday experience that they spark both curiosity and wonder. But we are not here to be afraid. We are here to explore, to understand, and to find peace in the infinite vastness of the cosmos. Let's start by gently unraveling the fundamental nature of black holes. At their core, black holes are born from the death of massive stars, stars that are far larger than our Sun. When a star exhausts its nuclear fuel, it can no longer maintain the balance between the outward pressure from its internal energy and the inward pull of gravity. As a result, the star collapses under its own weight. Imagine, if you will, a vast star once burning brightly, now shrinking and contracting, become denser and denser. As this collapse continues, the star's core grows smaller and smaller, its density increasing until the force of gravity becomes so immense that not even light, the fastest thing in the universe, can escape. The result is a region in space where light and all forms of space are trapped forever. This point of no return is what we call a black hole. Now let's take a step back and imagine the fabric of space itself. Space is not just void, it's more like a stretchy, flexible fabric that can bend and warp under the influence of massive objects. When you place a heavy object on this fabric, it creates a deep dent, pulling everything nearby towards it. In the case of a black hole, this warping of space and time becomes so extreme that it bends everything around it beyond recognition. A black hole isn't just a physical object like a planet or a star. It's a place where the very rule of the universe seems to break down. It's a zone where gravity is so strong that it stretches space-time itself, and the normal concepts of distance and time begin to blur. Imagine time itself slowing down as you approach one, as if the clock is winding down ever so slowly like a distant dream. Surrounding a black hole is a mysterious boundary known as the event horizon. This is the point beyond which nothing, not even light, can escape the black hole's grasp. If you were to cross this invisible line, you would be pulled in, and there would be no way to come back. The force of gravity near a black hole is so powerful that it warps both space and time in such a way that once something crosses the event horizon, it is forever lost to us, hidden from the view of the outside universe. Now imagine what would happen if you were to fall toward a black hole. As you approach it, the pull of gravity becomes stronger and stronger, but not evenly. The gravity at your feet, for example, would be much stronger than at your head, pulling you in different directions. This causes you to stretch out like spaghetti, an effect that scientists call spaghettification. Don't worry though, we are not going anywhere near a black hole, so there is no need to feel alarmed. This is just a way to understand the power of a black hole's gravity and how it affects objects that ventures too close to it. So, as we move forward, imagine black holes not as terrifying monsters but as mysterious and fascinating objects in space that push the very limits of our understanding. They remind us of the incredible power and complexity of the universe, where even the most familiar concept, time, space, and light, are bent and stretched to the point of wonder. Now that we have a basic understanding of what black holes are, let's take a closer look at the different types of black holes that exist in our universe. Just as stars come in many sizes, black holes do too, ranging from tiny stellar sized ones to the enormous galaxy sized giants. Each type has its own unique characteristic, and they form in different ways depending on the circumstances of their creation. Let's begin with the smallest type of black hole, the stellar black hole. These are born from the death of massive stars, stars much larger than our sun. When these stars run out of fuel, can no longer support their weight, they collapse in on themselves. This collapse leads to the formation of a black hole typically just a few times the mass of our sun. Though they are not the largest in size, these stellar black holes are incredibly dense. Imagine squeezing the mass of several stars into a space no larger than a city, or perhaps even smaller. This immense density creates an extremely powerful gravitational pull bending space-time around it. These stellar black holes are scattered throughout our galaxy, and while they are small in comparison to other types, their gravitational influence is anything but small. Next, we have a more mysterious category, intermediate black holes. These are black holes that fall somewhere between stellar black holes and supermassive giants we will talk about soon. Their masses ranges from hundreds to thousands of times the mass of our sun. The formation of intermediate black holes remains something of a puzzle to scientists. One possibility is that they are formed by the merging of several stellar black holes, each collapsing into one larger black hole over time. Another theory suggests that they may form in dense regions of space where stars are packed closely together, allowing them to grow through various processes. Though we have observed some of these black holes, many questions remain, making them one of the most enigmatic types in the black hole family. Finally, we come to the largest and most fascinating type of black holes, the supermassive black hole. These giants are truly awe-inspiring in their scale, with masses that can range from millions to billions of times the mass of our sun. Supermassive black holes are believed to exist at the centers of nearly every large galaxy, including our very own Milky Way. The one at the heart of our galaxy is known as Sagittarius A star. This supermassive black hole weighs about 4 million times the mass of our sun. Despite its enormous size, it is surprisingly calm, gently guiding the stars and gas in our galaxy with its immense gravitational pull. It's hard to imagine, but Sagittarius A star is located over 26,000 light years away from us, tucked deep within the Milky Way. Although it's massive and powerful, it doesn't consume everything in its path. Instead, it seems to quietly influence the galaxy, playing a central role in the dance of stars and planets around it. The idea that such large and powerful black hole can exist at the heart of galaxies like ours is a remarkable one. Scientists believe that these supermassive black holes may have been around since the earliest stage of the universe, helping to shape the galaxies we see today. Some even think that the galaxies collide and merge, the supermassive black holes at their centers might eventually combine, forming even larger black holes, and endless process of growth and evolution of the cosmos. As we reflect on these different types of black holes, stellar, intermediate, and supermassive, let's remember that each one represents a unique aspect of the universe evolution. Whether it's the quiet, unseen pull of a stellar black hole or the powerful gravitational force of a supermassive black hole like Sagittarius A star, they all remind us of the complexity and wonder of the cosmos. Now let's take a peaceful moment to dive deeper into one of the most fascinating features of a black hole, the event horizon. This is the ultimate boundary, the point beyond which nothing can escape, not even light. It's invisible, a mere concept that rather a physical surface, but its significance is profound. Imagine standing at the edge of a vast white cliff looking out into the endless cosmos. The event horizon is like that cliff. Once you cross it, there is no turning back. But don't let this idea fill you with fear. We are far, far away from any black hole, and even if we were near one, there would be no rush, no sudden fall. If you were to approach a black hole, the journey would be incredibly slow. You would experience an eternal fall through space, but it would feel almost peaceful. The passage of time would stretch, slowing down, giving you an infinite amount of time to observe the wonders of the universe as you drift toward the black hole. From a greater distance, a black hole might just seem like a dark spot against the backdrop of a star, a shadow in the vast sea of light. It's as if it's hiding in plain sight, blending seamlessly with the emptiness around it. But as you get closer, something remarkable happens. The stars and the light around the black hole begin to warp. They seem to bend and twist as if the black hole's immense gravity is gently pulling on them, drawing them toward itself. This is one of the most stunning features of a black hole, its ability to warp space and time. The closer you get to the event horizon, the more exaggerated this effect becomes. It's almost as if the entire sky around you begins to curve, creating a beautiful, surreal display of stars spiraling and bending, stretched and distorted by the black hole's powerful pull. But remember, this is all happening at a very calm, serene pace. There is no rush, no jarring force. Everything moves slowly, almost dreamlike. As the vastness of space wraps around you, enveloping you in a soft, comforting embrace, this quiet distortion of light reminds us just how vast and mysterious the universe truly is. The event horizon itself is an invisible boundary. You can't see it in the traditional sense, but you can feel its presence like an unseen force in the deep expanse of space. It's the point where everything changes: time, space, and even the path of light itself. But from a distance, as we float in the peaceful darkness of space, there is no need to worry. The event horizon is not something that can harm us. Instead, it's a reminder of the awe inspiring power of black holes, of the strange and beautiful forces that shape our universe. And as you settle into relaxation, let the vastness of space, along with the serenity of the event horizon, wash over you. Let its stillness carry you deeper into the tranquil embrace of sleep. Now let's dwell into one of the most mind-bending and beautiful aspects of black holes, the way they affect time itself. Time. as we experience it here on Earth seems constant. Each second, minute, and hour move at the same pace, unaffected by our surroundings. But in the presence of a black hole, time behaves in ways that can only be described as strange and in some ways almost dreamlike. Due to immense gravity of a black hole, time begins to slow down the closer you get to it. This phenomena is called time dilation, and it's one of the most intriguing effects predicted by Einstein's theory of general relativity. To understand it, imagine you are floating in a spaceship near a black hole looking at your own clock. As you observe it, you would see the seconds ticking away slower and slower, almost as if time itself is stretching, dragging each moment into peaceful eternity. Now imagine an observer far away, somewhere safe and distant from the black hole, perhaps in orbit around another star. From their perspective, they would see your clock moving at an entirely different pace. While your time seems to slow down near the black hole, their time would be moving normally, causing them to see your clock ticking more and more slowly as you approach the event horizon. This creates a curious effect where time for you near the black hole stretches out, while time for someone far away seems to be moving faster. It's as if the flow of time itself becomes warped, like the fabric of reality is gently stretching. If you were to stay near the black hole long enough, it might feel as though everything around you is frozen, suspended in a kind of slow motion dream. This showing of time near a black hole is not something that can be easily experienced on Earth, but it's an important reminder of just how strange and fascinating the universe can be. Imagine floating serenely through space, watching the stars drift by as time seems to stretch and elongate around you. The world outside would continue at its normal pace, but for you, everything would feel like it's gently slowing down, giving you an endless moment of peace and calm. In fact, the time dilation near a black hole is so powerful that it can create an effect that might seem even more incredible. If you were to stay near a black hole for a longer period of time, you could watch as time passes more slowly for you, while far away, centuries or even millennia could pass in the blink of an eye. You could witness the evolution of entire galaxies, the birth and death of stars, all while experiencing only a few months, as if time itself were suspended in the tranquil embrace of the black hole's gravity. This showing of time near a black hole is not just a theoretical idea, it has been confirmed by experiments here on Earth. For example, clocks on satellites in orbit experience a slight time dilation effect due to Earth's gravity, just as they would near a black hole. The stronger the gravitational field, the more noticeable the effect, stretching time like an elastic band, gently pulling and warping the moments around it. As you drift into a state of relaxation, imagine yourself suspended in space near a peaceful black hole with time itself stretching and slowing around you. Each second becomes softer, more fluid, like floating in a dream where you are gently carried along by the slow, rhythmic passage of time. This moment of peaceful, timeless serenity is a reminder of the strange and beautiful power that black hole holds over the very fabric of reality. And as you close your eyes and slip deeper into relaxation, let the concept of time dilation wash over you, its gentle stretching and slowing, like the very heartbeat of the cosmos itself, guiding you toward a calm and restful sleep. At the first glance, black holes might seem like threatening, destructive force, hungry giants that devour everything in their path, even stars. However, as we begin to understand their true nature, we realize that black holes don't just destroy, they also play a key role in one of the universe's most beautiful process, the creation of new stars. It's a remarkable cycle, one that shows the balance and interconnectedness of the cosmos. As a black hole pulls in matter from its surroundings, it creates a region known as the accretion disk. This is a swirling, rotating mass of gas, dust, and other cosmic material that spirals towards the black hole. The material in the accretion disk moves at incredibly high speeds, creating friction and intense heat. As the gas and dust collide and compress, they begin to glow, emitting light and radiation. This glowing disk can reach temperatures of millions of degrees, radiating energy out into space. But here is where the story takes an unexpected turn. The immense energy produced by the accretion disk can trigger something extraordinary. It can spark the birth of new stars. The intense radiation and energy released from the disk can cause nearby gas clouds to collapse, condensing under their own gravity and igniting the process of stellar formation. In this way, the energy from a black hole's accretion disk created by the destruction of matter can paradoxically help create new stars. It's as though the black hole is the catalyst, the fire that ignites a new cycle of creation. Stars are born out of the energy released by a black hole's insatiable pull, turning destruction into creation. These stars, newly formed, will go on to live their own lives, shining brightly in the vastness of space, creating their own solar systems, and perhaps even one day giving birth to a planet capable of sustaining life. This connection between black hole and star formation is a beautiful reminder of the universe's delicate balance. It's a cycle of life and death, of creation and destruction, all woven together in a cosmic dance that has been unfolding for billions of years. Black holes, in their role as both destroyers and creators, are a testament to the eternal rhythm of the universe, a peaceful, continuous process of evolution. Even in the darkest corners of space, where a black hole sits at the center, there is light and life being created. As stars form around the intense energy of a black hole, they continue the cycle of creation, ensuring that the universe remains a dynamic, ever-changing place. Each new star born from the ashes of old shines as a beacon of hope in the vast cosmic landscape. And so, as you settle into a deeper sense of relaxation, imagine yourself floating in the quiet of space, watching as stars are born from the energy of a distant black hole. The peaceful swirling of the accretion disk glows softly, like a cosmic womb where new stars begin their journey. The balance of creation and destruction plays out gently before you, a serene reminder that life and light are always emerging, even in the darkest of the places. With every breath, allow the peaceful imagery of the cosmic cycle to carry you further into rest. The gentle birth of stars, the swirling dance of gas and dust, and the calming presence of black holes remind us that in the vast expanse of the universe, even destruction has a purpose, leading to renewal, to growth, and to the continuous unfolding of life. Now let's turn our attention to one of the most dramatic events in the universe, the merging of black holes. Unlike the silent, isolated nature we often associate with black holes, these enigmatic objects can come together and collide, creating powerful ripples through space and time. These ripples are known as gravitational waves. It's as though the universe itself has a heartbeat, a deep rhythmic pulse that echoes across the cosmos. Gravitational waves are tiny distortion in space-time, barely detectable even with the most sensitive instruments. Imagine a calm, serene pond with a gentle breeze. The surface might ripple and shiver, but the effect is subtle and smooth. Similarly, gravitational waves stretch and compress space-time as if it's water, creating waves that travel vast distances across the universe. These waves are so tiny and fleeting that detecting them is an immense challenge for scientists. It requires incredibly sensitive equipment like laser interferometers used to catch even the faintest disturbance. When two black holes collide and merge, they release an immense amount of energy into the universe. It's like watching stars burst into flame, only much more intense and profound. The collision of these two black holes sends ripples of energy, a kind of cosmic pulse through space and time. These ripples reach us across billions of light years, allowing scientists to study the event indirectly. It's as though we are catching a glimpse of the universe's heartbeat, a constant reminder of the incredible power and energy that exist throughout the cosmos. Imagine floating peacefully through space, observing this cosmic dance of black hole. As they draw closer and closer to each other, they begin to emit bursts of light and radiation, like distant fireworks that fade and ripple across the fabric of space-time. The gravitational waves they produce stretch and compress space itself, creating waves of energy that ripple outward like concentric circles on a pond. These waves slowly spread throughout the universe, carrying the energy of the collision with them like the fading echoes of a distant explosion. It's easy to think of space as a silent void, but events like black holes mergers reminds us that the universe is alive, pulsating with energy and motion. The release of gravitational waves from these cosmic collisions is one of the most exciting discoveries in modern astrophysics. It connects us directly to some of the universe's most powerful forces, showing us that even in the darkest, quietest regions of space, there is movement, energy, and change happening all the time. As you listen to this story, imagine yourself drifting gently through space, observing the distant collision of black holes. The waves of energy radiate outward, stretching and compressing space itself, creating a soothing rhythm that echoes through the universe. It's almost as if the cosmos is breathing, pulsing in sync with the timeless dance of black holes. With each breath, feel yourself becoming part of this grand cosmic rhythm, allowing the peaceful image of space time bending and swirling to guide you into deeper relaxation. The black hole's merger and the resulting gravitational waves are not just distant abstract events, they are an intrinsic part of the universe's ongoing cycle, one that connects us all, bringing us a sense of peace and wonder as we drift off to sleep. As we have explored the immense power of black hole, it might be hard to imagine that even these incredible cosmic giants are not eternal. Like everything else in the universe, black holes too are subject to the passage of time. Over eons, they begin to lose their mass through a subtle yet fascinating process known as Hawking radiation, named after the brilliant physicist Stephen Hawking. Hawking's theory suggests that black holes are not completely black after all. They emit a faint radiation due to quantum effects near the event horizon. This radiation, known as Hawking radiation, slowly erodes the black hole, causing it to lose energy over time. It's as if the black hole is quietly shedding its power, losing bits of its mass in a gentle, invisible process. The idea of a black hole evaporating may sound strange, but it's a peaceful reminder that even the most enduring forces in the universe are not immune to the flow of time. However, this process is incredibly slow. For a black hole with the mass of our Sun, it would take longer than the current age of the universe for it to lose even a tiny fraction of its mass. So, while black holes are powerful and eternal in a human sense, they too are destined to change, to evolve, and eventually to rest. Imagine this quiet transformation where, over the course of billions, perhaps even trillions of years, the mighty black hole that once consumed everything around it begins to lose its grip on the universe. The radiation it emits is faint, almost imperceptible, a slow, almost mediative process. Over time, this radiation causes the black hole to shrink, gradually losing the mass it once had, until one day it will fade away entirely, leaving behind nothing but the echoes of the existence. The fate of a black hole is a quiet reflection of the universe's constant state of change. Even in the darkest corners of space, where black holes rule with their powerful gravity, there is a promise of transformation. There is no eternal stillness. Even the most powerful forces are subject to the passage of time. The black hole, which once pulled in light, gas, and even entire stars, will eventually rest, its once intense gravity fading into nothingness like the soft whisper of a star's dying breath. The cosmic cycle, where even the most powerful entities eventually rest, reminds us one of the peaceful inevitability of change. Just as stars are born and die, and as galaxies evolve and shift, black holes too have their life cycles. And when they do eventually vanish, it will not be with a dramatic explosion, but with a quiet, almost peaceful evaporation. The universe will continue on, and though the black hole itself may be gone, the ripples of its existence will remain in the fabric of space time, forever part of the great cosmic story. As you relax into the rhythm of your breath, imagine yourself floating through space, witnessing the slow and serene transformation of a black hole. You can see the gentle loss of mass, the radiation drifting off into the vastness of the universe like a whisper fading into the silence. The black hole grows smaller, quieter until it vanishes completely, leaving behind a peaceful void, a space where time continues to flow, where change is ever present, and where rest is a promise for all things, no matter how immense they may be. And just as black holes are subjected to the slow passage of time, so too are we. Everything in the universe, stars, planets, and even ourselves, is part of a never ending cycle of change. But within that cycle, there is peace and there is rest. Just like the black hole's eventual fading into the nothingness, we too find moments of peace, of quiet transformation, and of restful existence. Allow that calm, that eternal rhythm of change to guide you into a restful, peaceful sleep where the cosmos continues its cycle in perfect harmony. Let's bring our focus back to at our own home in the universe, the Milky Way galaxy. Deep within its heart, hidden at the center, lies a fascinating and powerful cosmic entity, a supermassive black hole known as Sagittarius A star. This black hole has existed for billions of years, quietly exerting its influence over the stars, planets, and cosmic dust that orbit it. But don't worry, there is no need to fear this immense force. Instead, think of it as cosmic anchor gently guiding the Milky Way, ensuring that everything in our galaxy moves in harmony. Imagine that at the very center of our galaxy, surrounded by billions of stars, sits a black hole with a mass greater than 4 million times the mass of our Sun. That's a truly staggering amount of mass, and yet, despite its size and gravitational strength, Sagittarius A star doesn't go on a rampage, devouring everything in its path. It doesn't consume stars or planets, but instead, it serves as a gravitational anchor holding everything in space. The stars and the other celestial bodies that moved around this supermassive black hole are not being drawn into it. Rather, they are gently guided by its presence, much like how the sun's gravity keeps the planets in its orbit. Sagittarius A star influence extends far beyond the event horizon. It shapes the very structure of our galaxy, guiding the stars and planetary systems in their complex dance across the vastness of space. So, as you close your eyes and relax into the peaceful rhythm of your breathing, imagine yourself floating through the Milky Way, surrounded by stars, and twinkle softly in the darkness. You glide closer and closer to the center of the galaxy where Sagittarius A star rests at its heart. You feel its gravitational pull, a gentle force drawing everything together in the most peaceful, harmonious way. The galaxy spins around it, stars and planets moving in elegant orbits, all guided by the quiet influence of the distant black hole. In this moment of stillness, let the calm presence of Sagittarius A star remind you of the balance and stability that exist in the universe. Just as the supermassive black hole guides the stars, you too can find your own center, your own quiet anchor as you drift into the peaceful sleep. As we near the end of our cosmic journey, let's take a moment to reflect on all that we have discovered. We have explored the vast mysteries of black holes, these powerful enigmatic entities that dwell in the heart of the universe. They are both awe inspiring, serene, reminding us of the delicate balance that exists between creation and destruction, life and death, stillness and motion. Black holes, with their immense gravity and invisible presence, may seem intimidating at first, but as we have seen, they are not forces of destruction but of transformation. They represent the end of one phase of existence but also the beginning of another. Within their depths, matter is compressed into something unknown, but from the edges of their event horizon, the universe continues to evolve. They serve as a reminder that even in the darkest corners of space, there is always the potential for something new, something beyond our current understanding. As you prepare to drift into a peaceful sleep, let the calm of the cosmos warp around you. Picture yourself floating gently through the vast expanse of cosmos, far from the noise and buzz of the world below. In this quiet space, time seems to stretch into infinity, and you realize that you are part of something far greater than yourself. You are a small part of a vast and ever changing cosmos, a universe that has existed for billions of years and will continue to evolve long after our time. And just as the stars and galaxies dance through the void, so too does the calmness of space provide a peaceful rhythm that lulls into a deep, restful slumber. In the presence of black holes, there is no need to fear, there is only wonder and peace. They are not just cosmic mysteries but symbol of vastness and the unknown beauty that the universe holds. They remind us that the cosmos is a place of both stillness and movement, a place where time and space are intertwined in ways we can only begin to understand. So, as you close your eyes and let your body relax, remember that you are part of a grand cosmic journey. You are connected to the stars, to the planets, to the galaxies, and to the black holes that shape the universe. With each breath you take, imagine yourself floating effortlessly through the night sky, enveloped in the infinite darkness, at peace with the rhythm of the universe. Rest in the knowledge that the universe is ever evolving, filled with wonder, mystery, and beauty. And as you drift off to sleep, let yourself be reminded of the eternal, peaceful dance of the cosmos where time slows, stars bend, and the vastness of space invite you to rest, to dream, and to be at peace. Good night, and may the calm of the cosmos guide you into a restful and peaceful sleep.